My dear students, today I am going to discuss physics for class 10, the chapter of light. Now, one student from Barpeta, Amlanjuti Pathak, he asked a question. The question is this: what is magnifying glass? How does it work? What is magnifying glass? How does it work? Now, magnifying glass is converging lens, that is convex lens. Now, let us see a diagram. Now, this is a converging lens or convex lens. All right. This is optical center O. Now, this is a focus. This side, this is the focus. Now, consider an object here. Now, magnifying glass is used to see magnified image of small object. For example, for reading purpose, small letters can be magnified so that it becomes easy to read. So, suppose this is a letter. Suppose this AB is a letter. Now, you are positioned here. Your eyes are on this side. So, you are using a magnifying glass to see this letter. Now, the image of this virtual image of the magnifying glass will be formed somewhere here. So, your eyes are here. You are positioned here. The image will be formed here. Now, how will the image be formed? Let us see. Now, from here, so one ray parallel to the principal axis will fall on the lens and it will pass through focus. All right. So, this is the focus of this lens. So, this ray parallel to principal axis will pass through the lens and then pass through focus. All right. Then another ray through optical center, it will go straight. So, any ray through the optical center of a lens is not deviated, it goes straight. So, this ray is going straight through the optical center. Now, you see these two rays are diverging, they are going away from each other. These two emerging rays are going away from each other. So, there is no chance of their meeting. They will never actually meet. All right. But they will appear to meet if you produce them backward. So, you see this ray. Now, this ray appears to come from this point and this ray appears to come from this point. All right. So, I have produced them by dotted line. Now, this is the image of this point A. So, this is A dash. It is the virtual image of A. Now, from here, if you draw a perpendicular, this object is perpendicular to the principal axis. Therefore, image also will be perpendicular to the principal axis. So, this A dash B dash, this is B dash. So, A dash B dash is the virtual image of AB. All right. Now, these rays will fall on the eyes of the observer. So, these rays, they will never meet, but they will fall on the eyes of the observer. So, if the observer's eye is positioned here, then for the observer, the rays will appear to come from A dash. Although they are coming from A actually, but for the observer, the rays will appear to come from A dash. So, the observer will see the image of A at A dash. That way, whole image of AB will be seen at A dash B dash. So, you see A dash B dash is magnified. It is much larger than AB. So, this is how the letter AB, suppose this is a letter, object is a letter. The letter has been enlarged, has been magnified. And this lens is working as what? As a magnifying glass. So, this is how a magnifying glass works. Now magnifying glass is a, so what is magnifying glass? Magnifying glass is a converging lens or convex lens. And how does it work? This is how it works, by producing a magnified virtual image of a small object so that it becomes easy for an observer to see. And that is how this magnifying glass is used, to read small letters, to see small object, the enlarged image of small object. All right. Okay, I hope Amlan Jyoti from Barpeta is satisfied. Okay. All right. Now, yes, now I want to discuss some numerical problem related to lens and mirror. Now, there is a kind of problem which students find difficult to solve. 80% of the students fail to solve because they somehow make mistake in signs, where positive, where negative, where there should be negative they put positive, where there should be positive they put negative. So these signs actually are the students find difficult. So let me simplify the process. Okay, now suppose this question: a lens of focal length 30 centimeter forms an image twice as large as the object. That means magnification is 2. Find the object distance. I followed? I read again. A lens. Now, what kind of lens? It is not mentioned in the question. Just a lens. A lens of focal length 30 centimeter forms an image twice as large as the object. That means magnification is 2. Find the object distance. All right. Now, you see, this is a question of forming enlarged image twice as large as the object. Now, enlarged image is formed only by converging lens or convex lens. The other lens, concave lens, always forms smaller image, reduced image. Now, the question is about enlarged image, twice as large as the object. Therefore, the lens must be convex lens. It is not mentioned, but you have to learn, you have to know the lens is what lens? Converging lens or convex lens. Now, convex lens can form enlarged image in 2 ways: by forming real image or by forming virtual image. Therefore, you have to consider both the cases. First case real image, second case virtual image, and then you have to find the object distance in both the cases. All right. First of all, let us consider the lens forming real image. So when the image is real, so let us first see when the image is real. Okay. Now again, let me draw the diagram. So this is convex lens or converging lens. All right. Now this is the object. Suppose this is the object. Okay. Now the image is formed, real image. The real image is formed on the other side, somewhere here. How the image is formed, those rays I have not shown. So there will be rays. I mean, you have learned how the image is located by drawing at least 2 rays, isn't it? So this is the image and this is the object. So let us say AB is the object and suppose PQ. PQ is the image. Now this is a real image. All right. Now this relation, object by object distance equal to image by image distance. So this is an important relation. Object by object distance equal to image by image distance. This is true for lens as well as for mirror. Actually, this comes from this relation, h dash by h equal to v by u. So image distance, object distance, size of image, size of object. Now from here what you get? h by u equal to h by u equal to h dash by v. So that is what I am writing here. H is object, u is object distance, h dash is image, and v is image distance. So size of image by size of object, image distance by object distance. So from here we get this important relation. All right. Okay. Now So object, now see here, object and image. Now image is twice the, here the question is given, the image is twice as large as the object. The image is twice object, therefore the image distance will be twice object distance. So the image distance will be what? Twice the object distance. Have followed? So image is twice the object, as the question says, therefore image distance must be twice the object distance. Now suppose object distance, now this is the object distance, this is object, this is optical center, so this is the object distance. Now let us say it is x. Now x is a numerical value, we are not considering sign here, just the numerical value. So this object distance is suppose x is a numerical value of the object distance, therefore this distance will be twice x. Followed? So object distance x, the image is 2 times the object, therefore image distance will be 2 times the object distance. Image distance 2 times the object distance. All right. So if this is x, that will be twice x. Followed? Okay. Now we can use that Lenz formula. So Lenz formula says what? Now you see, let us first of all write this u equal to what? Now this is x, therefore u will be minus x on the left side. Then v, image distance, v is what? Twice x, right side, so positive, isn't it? And what is f given in the question? F is given 30 centimeter. Now for this lens, focal length is what? Positive, because this side. Now we can use the Lenz formula. So what is the Lenz formula? 1 by v minus 1 by u equal to 1 by f. Now 1 by v. So 1 by v, what is v? 2x. Minus 1 by u, what is u? Minus x. Equal to 1 by f. So 1 by 30. Now we can solve this equation to find the value of x. So up to this, see, I hope that things are clear. X is the numerical value. Remember, numerical value of object distance. Twice I say x is the numerical value of the image distance. Now with proper sign, x, this u will be minus x. This side, v will be twice x, positive, isn't it? Then focal length of this lens is always positive. Now by solving this, we get just matter of solving. Just matter of solving, what we get? Twice x equal to 3 to 90. Therefore, x equal to 45. So this is the value of x. So this x is what? 45 centimeter. So focal length was given 30 centimeter, all in centimeter. So this we have found out 45 centimeter. That is the answer. The question was find the object distance. So object distance is what? 45 centimeter. Now image distance will be 45 into 2, 90 centimeter. So you see, this is how you can handle the problem of science. So again I say, students make mistake mainly in science, where there will be positive, where there will be negative and all that. You followed? So you take the numerical value, then you put the proper sign, use a Lenz formula, you get the answer x equal to 45. So answer is 45 centimeter. Okay. Now this answer we got by considering real image. Now let us consider the other possibilities. Other possibilities is what? Virtual image. Virtual image, okay. Okay, now let us see what happens when the image formed is virtual. The image formed is virtual image. Okay. Now this lens, how does it form virtual image? Yes, in answering the question in the beginning, I already drew it. So this is the object, all right. This is the object and this is the image. In case of virtual image, object and image are on the same side. In case of real image, object is on the left side, then image is on the right side, on opposite sides. But in case of virtual image, both will be on the same side. So this is object AB and this is image, suppose PQ. All right. Now this is optical center. Okay. Again, like before, Like before, what you get, that relation, that is image distance is equal to 2 times the object distance. So as I showed you in the previous case, image distance equal to 2 times the object distance. Now let us take the object distance. That means this is the object distance here. This is object distance. Let us take it x. Then image distance, so this distance. So the optical center, this is object. Therefore, this distance is what? Object distance x. Now this is optical center, this is image. So this distance will be twice x, because image distance is 2 times the object distance. Okay. Yes. Now we'll use that proper sign. So f is what given? Plus 30. Focal length is given 30. This lens. Then u equal to what? Minus x. Object distance is always negative in case of all mirrors, in case of all lens. U is always negative. So this is numerical value x. This is numerical value twice x. So minus x. Then v. Now here image distance is also on the left side. So it will be negative. So minus twice x. Minus twice x. All right. So focal length u minus x and v this side. So minus twice x. Now put the values in the lens formula. Let us see. So using the lens formula, 1 by v minus 1 by u equal to 1 by f, isn't it? So 1 by v, what is v? Minus 2x, minus 2x, minus 1 by u, what is u? Minus x, equal to 1 by f, what is f? 30. Okay. Now this is minus 1 by 2x. This is minus minus plus 1 by x equal to 1 by 30. All right. Yes. Now let me write here. So here LCM 2x. 2x is LCM. What do you get? 1 plus minus 1 plus 2. Minus 1 plus 2. LCM is 2x minus 1 plus 2, that is 1 by 30. All right. So here 1 by 2x equal to 1 by 30, equal to 1 by 30. Right. Equal to 1 by 30. Therefore x equal to 15. This is answer, 15 centimeter. So this x is what? 15 centimeter. This is 15 centimeter object distance, and image distance is 2 into 15, that is 30 centimeter. So in this case, in case of virtual image formation, what is the object distance? 15 centimeter. In case of real, it was what? 45 centimeter, isn't it? So you see, this is how, if we use x, if we use the x as numerical value for object distance, then the problem of sign is solved. But if you do only with u and v, you can do, no doubt, but then many students make mistake in sign. Okay. Yes. Now let us see the same questions for mirror. For mirror. Okay. Question is same. Now which mirror forms real image and virtual image, both kind? Concave mirror. Concave mirror. You see. Yeah, let me draw and show you. This is a concave mirror. This is a concave mirror. Concave mirror or converging mirror. This is a pole, isn't it? Okay. Now, suppose this is an object. This is an object between focus and center of curvature. This is an object between focus and center of curvature. So its image will be formed. Real image will be formed somewhere here. Yes, this is the real image. So suppose AB is the object, and here suppose A dash B dash. A dash B dash is the image. Now this mirror, concave mirror or converging mirror, will form real image like this. The object should be between focus and center of curvature. Then the image will be magnified. Now here the case of magnified image, twice the object. So this is twice this size. All right. Now same question as I told you. Now in case of mirror, the question will read like this. You see, just replace the word lens with mirror. The question will be like this: a mirror of focal length 30 centimeter forms an image twice as large as the object. Find the object distance. The question is as before, only in case of lens it is mirror. So focal length is 30. Focal length is 30. Yes. Now, so this is a real image. So again we have to consider the two situations, because this mirror can form real image as well virtual image. In the question again it is mentioned only mirror. Which mirror it is not given. Now you have to know those important 8 diagrams in your book. So you have to know immediately that the mirror must be concave mirror, because only concave mirror can form magnified image. The other mirror, convex mirror, forms what? Always reduced image, doesn't it? Okay, so this is object, this is image. Now this is real image. Now this distance will take to be x, the distance between the pole and the object, that is called object distance. And this distance between the pole and the image, this will be image distance. So twice x. All right, just that thing, that same relation as before. So I showed you already in case of lens, the same thing. Okay, so this will be x. So this image is twice the object, therefore image distance will be twice the object distance. So remember this simple relation: if image is twice the size of object, then image distance will be twice the object distance. If image is 4 times the size of the object, then image distance will be 4 times the object distance. Like that. If image is 3 times the size of the object, then image distance will be 3 times the object distance. All right. So if this is x, numerical value, then this will be twice x. Why twice x? Because it is given the image is twice the size of the object. Okay. Now let us put proper sign. So here f. Now for this lens, focal length is negative. Concave mirror. Sorry, not lens, mirror. So for this concave mirror, focal length is negative. So it will be minus 30. Because this side. All right. Focal length minus 30. Then u is always negative, minus x. Then f, v also here minus. You see, this is on the left side of the mirror, both will be negative. And of course focal length also negative, all the three are negative. Now let us use the mirror formula. 1 by v plus 1 by u equal to 1 by f. All right. Now 1 by v. So what is v? Minus x. V is minus 2x plus 1 by u is minus x, equal to 1 by minus 30. All right. So next line will be minus 1 by 2x minus 1 by x minus 1 by 30. Now see, all are minus, minus, minus. We can change all the signs. We can make all plus. This is a rule of equation. All the three terms are negative, so we change them all make positive. Just rule of equation. Okay, now let us solve this one, this side. So now LCM is what? Twice x. LCM twice x, so you will get 1 plus 2, that is equal to what? Equal to 1 by 30. All right. So this from here, twice x is LCM, 1 plus 2 equal to 1 by 30. 1 by 30. So what you get from here, twice x equal to 90. So x equal to 45 centimeter. This is the answer. All right. So this is 45 centimeter. Object distance 45 centimeter. Image distance 45 into 2, 90 centimeter. Now when the image is what? When the image is real. Okay. Now next situation, when the image is virtual. Okay. Let us see now. Next, when the image is virtual. When the image is virtual, let us see the drawing. Okay, I hope this part is clear. So here what we got the answer, when the image is real, what should be the object distance? 45 centimeter. Okay. All right, now let us see when the image is virtual. Okay. Yes, now in case of real image, object and image are on the same side. In case of virtual image will be on the opposite side. This is the drawing. You have to be acquainted with all the drawings, so take care. This is a mirror. Now this is the focus. This is the pole. Now object must be between pole and focus. Yes, this is the thing. In order to form magnified virtual image by this mirror, the object should be between pole and focus. Not exactly in between, I mean somewhere in between. Okay. Now the image will be formed here. So this will be the image. I have not shown the rays. This will be the image. So suppose AB is the object. AB is the object and A dash B dash. All right. So this is A dash. This is B dash. A dash B dash is the image. AB is the object. A dash B dash is the image. Now this image is twice the object. Image is twice the object. Therefore, image distance will be twice the object distance. Now this is the image distance, and this is the object distance. So this object distance, let us take again x. Therefore, this image distance will be twice x. So image is twice the size of object. Therefore, image distance will be twice the object distance. So object distance numerical value is x. Therefore, this numerical value will be twice x. Okay. Yes. Now let us put the values. Let us put the values with sign. Now focal length is 30. Now this mirror negative. This mirror focal length is negative. Then u equal to minus x. All right. So now v will be plus 2x. It will be plus 2x. So it is on the right side, no? So it will be 2x no doubt, but plus. Okay. Now let us use the mirror formula. 1 by v plus 1 by u equal to 1 by f. All right. Let us use the mirror formula. So what we get? 1 by v. What is v? 2x plus 1 by u. What is u? Minus x equal to 1 by f. What is f? Minus 30. Is it clear? Okay, now here LCM. LCM will be twice x. LCM will be twice x, so 1. Now here plus into minus minus, so minus 2. Just simplify. That simplification you should know. Equal to minus 1 by 30. All right. Then from here what do you get? Twice x. This is minus 1 equal to minus 1 by 30. Now both side minus you can cancel. That means you make them plus. So what do you get? 2x equal to 30. So from here what do you get? 2x equal to 30. 2x equal to 30, which gives what? X equal to 15. X equal to 15 centimeter. This is the answer. So putting these values in the mirror formula, we solve. That solving part you should know. Okay. Then this way what we get? Twice x equal to 30, x equal to 15 centimeter. So that means this is 15 centimeter and this is 30 centimeter. So here the answer is 15 centimeter. So you see, this is a method assuming x as a numerical value of object distance. X as numerical value of object distance. So then in this case, if we use this method, then you have to be bothered about sign only in this particular situation, only when you put f, u and v. You followed? And then obviously after getting these values with proper sign, then simply put in the formula. So I have found using this x method, students can handle that problem of sign very easily. Okay. All right. I hope this discussion has been useful to you. Okay then. So today we close. So thank you and good night.